Climate change is one of the most pressing challenges we face today, and CO2 capture technologies are emerging as a promising solution. These technologies are designed to capture carbon dioxide emissions from various sources before they can enter the atmosphere, and they hold incredible potential for transforming industries and reducing greenhouse gas emissions. Let's dive into three main CO2 capture techniques. First up is post-combustion capture. This method is particularly relevant for existing power plants and industrial facilities. After fossil fuels are burned, the flue gas contains CO2 along with other gases. Post-combustion capture uses chemical solvents to absorb the CO2 from this flue gas. Once captured, the CO2 can be compressed and transported for storage or utilization. This technique is crucial because it allows us to retrofit current infrastructure, making it a viable option for reducing emissions without needing to overhaul entire systems. Next, we have pre-combustion capture. This technique is often used in gasification processes, where fossil fuels are converted into a mixture of hydrogen and carbon dioxide before combustion. By capturing the CO2 at this stage, we can produce hydrogen, a cleaner fuel that can power everything from vehicles to power plants. This not only reduces emissions but also creates valuable hydrogen that can help transition us to a more sustainable energy future. Then there's oxy-fuel combustion, which is a bit different. In this method, pure oxygen is used instead of air for combustion. This results in a flue gas that is primarily water vapor and CO2, making it easier to capture the CO2. The water vapor can be condensed, leaving behind concentrated CO2 that can be stored or utilized. Oxy-fuel combustion is particularly exciting because it can significantly reduce the volume of emissions, making the capture process more efficient. Once we capture CO2, we need to think about what to do with it. There are two main approaches: storage and utilization. CO2 storage involves injecting the captured gas deep underground into geological formations, where it can be safely contained for centuries. This is known as geological sequestration. On the other hand, CO2 utilization transforms captured carbon into valuable products. For instance, it can be used to create synthetic fuels, building materials, or even in the food and beverage industry for carbonation. This not only helps reduce emissions, but also creates a circular economy where waste is turned into resources. The importance of these technologies cannot be overstated. They provide a pathway to significantly lower our carbon footprint while still relying on fossil fuels during the transition to renewable energy sources. By investing in and advancing CO2 capture technologies, we can make a substantial impact on our climate goals. As we move forward, it's crucial for everyone to engage with this topic. Whether you're a policymaker, a business leader, or simply a concerned citizen, understanding and advocating for CO2 capture technologies can drive the change we need. Together, we can harness these innovations to combat climate change and create a sustainable future for generations to come.